Good afternoon, grade 7 students. In this video, we are going to learn how to draw a graph. What are the components of the graph? What the meaning of x-axis? What the meaning of y-axis? What are the components needed to draw the graph? And here we go. First, we have to draw the graph. In order to draw a graph, you have to use the data available. You have to use the information or the given that's available either in the table or in the text in order to draw the graph. Here, first we're going to start with the curve. Next, we will draw a histogram and also a pie chart. First, we will use to start the curve. We have to use the details of the given document. You have to add a title for the graph. So the first component for the graph is you have to add a title. So this is number 1. We have to add a title for the graph. This is first step. First step for the graph, we have to add a title. Next, number 2, we have to label the axes, the x-axis and the y-axis. The x-axis and the y-axis. X-axis with the variable and the y-axis with the result. And we have to put the units and we have to put the scale. So number 2, label the axis. Number 3, we have the units and we have the scale number 4. What the meaning of x-axis and what the meaning of y-axis? This is the graph. This is the first step to draw the graph. The graph is going to be like this. Okay? This one, the horizontal line, it represents what's known by, this is the x-axis. Okay? We took this in math last year, how to plot a point. So this is the x-axis. And the vertical one, this line, it represents the y-axis. Okay? So first we identify what is the y and what is the x. The x-axis is the horizontal line. This line is the x-axis. And the vertical line is called the y-axis. So this is the first note about the x-axis and the y-axis. The x-axis is the horizontal one. This is called the x-axis. And the y-axis, the vertical one. This is called the y-axis. Okay? This is the first step. Let's move now to the second slide. Application. This is a very important application in order to identify how to draw the graph. Let's start in this question. Respiration. So first we place a green aquatic plant in a large test tube that is filled with water. So we placed a green aquatic plant in a large test tube. This test tube was filled with water. Then we connect an oximeter to the test tube. Oximeter, what is the function of the oximeter? Oximeter is used to measure the amount of oxygen in the tube. It's used to measure the amount of oxygen gas. That's why it has the name oximeter. It measures the amount of oxygen. We start recording the amount of oxygen every 1 minute. And the results are shown in the table below. So we have the time in minutes, 0, 1, 2, 3, 4, and 5. The amount of oxygen gas for the aquatic plant, this is the volume in centimeter cube. So at time 0, the amount of oxygen was 10 centimeter cube. At time 1, it was 8 centimeter cube. At time 2, it was 6 centimeter cube. At time 3, it was 4 centimeter cube. At time 4, it was 2. And at time 5, it was 0. So the first question here, let's pick out, let's move for Lynn Khalifik. Lynn, good afternoon.
Good afternoon.
What do you think the amount of oxygen is increasing or decreasing? At time 0, it was 10. After 5 minutes, it becomes 0. What do you think? It increases or decreases?
0.
Yes. So at 10, at time 0, and then it becomes 0. It decreases. What do you think? What is the reason behind this? why the amount of oxygen decreases. Do you know why? So we place a green aquatic plant in the test tube and we measured the amount of oxygen. At the beginning of the experiment at time zero, it was
because it has
because
be- because it has the aquatic plant in it.
the aquatic plant is what? Is doing what? It's consuming the oxygen gas. Okay? That's why the amount of oxygen is
Yes,
decreasing. Okay? Thank you, Lean. Let's move
decreasing.
now to, let's have Talin. Talin Zen. Do you hear me? I think she had a problem in your unmuting. So let's move now to another Talin. Let's move to Hassan Isrur. Good afternoon, ya Hassan.
Good afternoon.
Okay, Hassan. The table is in front of you. We have the time and the amount of oxygen gas for the aquatic plant. Okay? Did you watch the video?
Yes.
Okay, Hassan. So what do you think? Which one of these should be on the x-axis and which one of these should be on the y-axis? Let's see if you remember what's mentioned in the video.
The x-axis the amount of the oxygen.
Amount of oxygen and the y-axis is the time, right?
Yes.
Okay, so what do you think, Selena? Thank you, Hassan. What do you think, Selena? Time should be on the x-axis or the amount of oxygen gas for the aquatic plant should be on the x-axis? What do you think? Yes, Selena? Good afternoon. Selena? Oh, she had a problem maybe. So let's move to Adam Arauni. Adam, what do you think? Which one should be
Yes,
on the x-axis, Adam, and which one should be on the y-axis? The time should be on the x or the y?
the time on the y-axis and the oxygen gas for the aquatic plant on the x-axis.
Okay, let's see here. Oh, thank you, Adam. Let's move now to Michael. Good afternoon, Michael.
Hi.
What do you think, Michael? Which one should be on the x-axis and which one should be on the y-axis? First of all, let's draw the x and the y. This is the figure of the graph. This is the x-axis and the vertical is the y-axis. Which one should be on the x and which one should be on the y?
Amount of oxygen gas for the aquatic plant
Yes,
on the x-axis.
x-axis, which one? The horizontal or the vertical?
The horizontal.
The
And I
horizontal.
mean the vertical.
The vertical or the horizontal?
Vertical.
Vertical is the y-axis.
No, the x-axis.
The x-axis is here, yeah, Michael. It's on the x-axis. This one is the horizontal one. This is the x-axis. And the vertical is the y-axis. This one is the y-axis. Okay? So always
Okay.
and always pay attention. Which one is found on the upper side of the table? Time or amount of oxygen gas for the aquatic plant?
Amount of oxygen gas.
Which one is found in the upper side of the table? This is the table. Which one is up and which one is down in the table?
Time is
Time
up
is
and
always,
amount of
yes, always and always and always. Keep it in your mind. Always, the one in the table up should be down in the graph. So the time is up in the table. Where it should be? It should be down in the graph. So the time should be here on the x-axis. Here is the time. Time in minutes. And the one that's below in the table, amount of oxygen gas for the aquatic plant will be where? Will be up in the
up
graph.
in the graph.
Okay, so amount of oxygen gas. Here are the amounts. Okay, so here let's repeat this. Who can repeat this for me? In the table, and in the graph. The one is found up in the table. Let's have Carlo. Carlo, what do you think about this? The one's found up in the table, where it should be in the graph. Carlo, do you hear me? Carlo? Yeah, the problem maybe. Okay, let's hear. We have Ali Basma. Yes, Ali, what do you think?
The one that is found up
Yes,
on
in the
the
table should be where in the graph?
table should be on the x-axis, and the
Excellent,
one
should
below
be the down. And the one that's found below in the table should be up
on
in
the
the graph,
y-axis.
on the y-axis. Excellent. Thank you, Ali. Yes, Hassan, do you have a question you have to ask about it before we continue? Hassan Watfa? Hassan, do you have a
No.
question? Okay, thank you, Hassan. So always the one that's found in the table, that's found up, should be down in the graph. And the one that's found down in the table should be up. They are opposite. So always the time should be down, should be on the x-axis. This is the x-axis. And the amount of oxygen should be on the y-axis. So this is for the graph. Okay? So always the one that's found up in the table should be down in the graph, should be on the x-axis. And the one that's found up in the found down in the table should be up in the graph. Let's move now to I wanna move to Laris. Can you repeat what we have explained before about the graph and the table? I can't hear. Maybe from my connection. Okay, no problem, Laris, no problem. So we can move to Razan. Razan, can you repeat what we have explained about the table and the graph?
Yes.
Yes, so the one that's found up in the table, where it should be in the graph?
It should be on the x-axis.
Excellent,
Down.
which is down. Very good. And the one that is found in the table should be where in the graph?
On the y-axis.
Excellent, excellent. Thank you, Razan. Thank you for this. So here, always and always and always, the one that's found up in the table should be down on the x-axis of the horizontal line. And the one that's found down in the table should be up on the vertical line. So here, this is the table. So here, what do you put here? We place the time that's found on the table and above, it's placed down. And here we put a title for the axis. You have to put a title for the axis, which is time in minute. And we have to put an arrow here because we are moving in this direction. Also, you're using, for example, the graph paper. Every box represents 1 centimeter. If you're using a math copybook, every box, you will take it to represent 1 centimeter. Here, we start at 0. So this is the point of intersection. Always the point of intersection is the 0. Then I have to move 1 by 1. I don't have to move, for example, 0, 1, then 1, move to 4. No, I have to start step by step. Either I start 1 by 1, 1, 2, then move to 3, then move to 4, to 5, and if we have 6, we move to 6. While on the y-axis, we place the amount of oxygen for the aquatic plant. Here, the title of this. If you mention here, how did I move here on the y-axis? Let's move to something in here. Let's move for Reem Safiyaddin. Reem, do you hear me, Reem?
Yes,
Good afternoon, Reem.
good afternoon.
And the x-axis, where is the x-axis? This is the x-axis, the one that is found in the horizontal, right? This is called the x-axis.
Yes.
Okay, how did we move? We move 1 by 1, we move 2 by 2, or 3 by 3. What do you think?
We move 1 centimeter.
We move 1 by 1. So we move 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So we move 1 by 1. So every 1 centimeter, it represents how many minutes?
1 minute.
Excellent. So this is the scale. On the x-axis, every 1 centimeter, it gives how many minutes? 1 minute.
1 minute.
Thank you. Thank you, Reen. Moving to Zainab Bustani. Zainab, good afternoon. Good afternoon, Zainab. You should be here as Zainab. Let's move to another one. Let's move to Maya. Maya. Good afternoon, Maya.
Good afternoon.
Okay, so as Reem said that we moved one by one on the x-axis, right? So we moved every 1 centimeter represent 1 minute. On the y-axis, what do you think? How did we move? Yes, Mia? How did we move on the y-axis? 1, 1, 3, 3, 4, 4, 5, 5. What do you think?
We minus 2.
We moved by 2. So we moved 2 by 2. So every 1 centimeter represent 2 centimeter cube.
Yeah.
This is on the y-axis. So I move 2, 4, 6, 8, and then 10. This is the scale. This is the scale here. We mentioned the scale. On x-axis, every 1 centimeter, it gives 1 minute. While on the y-axis, every 1 centimeter, it gives 2 centimeter cube. We move now to the title. Title of the graph. Always you have to say these words. Graph showing the variation of the y-axis. What is on the y-axis? The amount of oxygen gas for the aquatic plant, and you have to mention the unit in centimeter cube as a function of time in minutes. So time in minutes. Always graph showing the variation of what? Of the y-axis, which on in the y-axis as a function of the x-axis. What is on the x-axis? The time as a function of time in minutes. So here, this is the title. So always you have to say graph showing the variation. This is always variation of what? On the y-axis, what do we have? The amount of oxygen gas for the aquatic plant. Which unit? Centimeter cube. As a function of what? A function of the x-axis, which is the time in minutes. This is the title. Now, let's move to plot the graph. Let's plot the graph. First, if I want to plot the graph, I have to start from the beginning. From the beginning, at time, we have which time? At time 0, it was, at time 0, it was 10. At time 1, it was 8. At time 2, it was 6. Time 3, it was 4. Time 4, it was 2. And time 5, it was 0. So let's start step by step. Starting with this, we will start at time 0. Where is time 0? Here is time 0. And what is the amount of oxygen gas for the aquatic plant in centimeter cube? It was 10 centimeter cube. So here we have to put the points. Then at time 1, where is time 1? Here is time 1. So I have to move with a pencil, and the graph should be drawn using a pencil and a ruler. No pens. You are not allowed to draw a graph using a pen. So here you have to complete it, and here they meet at this point. So at time 1, it was 8. At time 2, it was 6. So this is 2. And then whenever we reach the 6, we have to put it here, and here we put the point, the 6. And at time 3, it was 4. So here 4, we move here 4, and we cut it into 3, and here is the point. Imagine that this line is not found yet. And then at time 4, it was 2. So sure, you have to draw it using a ruler, and then you connect it here. This is at time 4. And at time 5, it was 0. This is at time 5. Then we connect the line using your hand, or if you want using a ruler, it's okay since it's a straight line. So here, this is the graph. What is the graph? I gave it the title for the axis, and here I put the arrows. Since I'm moving in this direction, you have to put the arrows, and I draw it using a pencil, and sure, drawing it using a ruler, and for sure, we have to give it a scale. This is the scale. Or if I want to draw another scale, we can do it like this. This is another way for the scale if you want. you can choose the best for you. This is another way for the scale. Sure, it should be straight using a ruler. So here, every 1 centimeter to present how many minutes? Every one to present 1 minute. So I can write here 1 minute. And here on the y-axis, every 1 centimeter, it represents 2 centimeter cube. So I write here 2 centimeter cube. This is another way for the scale. So this is another way for the scale. If you want to use this or you want to use this, they are the same. But this one, I think, is easier and faster and it saves time. Okay, so you can draw it in the graph. Also, you don't have to forget to give the title. Graph showing the variation of what? Of the y-axis, the amount of oxygen gas as a function of the time in minutes. So this is everything related to the graph. So graph, you have to give it a title. You have to know which one in the x-axis and which one on the y-axis. You have to give it a title, a scale, and if there is more than one line, you have to give them a legend, and we will check this later. Okay? This is everything related to the graph. Thank you.